Alright, quick test of mic volume. Alright, hey, it's Nick with Program Practical. Doing a live stream today of to start just one coding challenge off of codekata, if I'm saying that right. Anyway, so I was sent to this site from I was talking to I don't know what his actual position is. I don't know if he's a recruiter or just, management. But like, what do they do when they do hiring and stuff like that? And he's like, well, we like to do a few programming problems off of a couple sites, and codekata was one of them. I was like, I'll check that out because it's always good to keep your skills sharp for interviews. And so I like to interview even when I'm not looking for a job, but also just talk to people who do interviews. Like, what do you guys use? Do you just do whiteboard stuff? And like the last one I went to had me do a FizzBuzz thing, and then they actually wrote a few things up on a board, and they were like, what is the expected output from this equation? So that was good. And then ones like this other company is like, oh, we like to have people bring their laptops in, something they're familiar on. And then we'll have them do one or two problems off of like one of these sites. And codekata was one of them. I've never heard of codekata before, so I was like, well, I'll take a look at it and see what they have. I do stuff like HackerRank and stuff like that to keep some of the more skill-based stuff sharp. And codekata is more interesting in my opinion, just from the base of where I've started, and that like some other sites, which I can't recall off the top of my head, it doesn't, unlike HackerRank has everything like closed in the browser. Well, with codekata, it just gives you some goal specifications and the problem, and then gives you the test data, and then you're supposed to build your own little project to do. And I like that because like with Ruby in HackerRank, it's testing my results, but I'm not writing any of the test. I'm not doing the project files. I'm not organizing the code. And so while it is good, it's important to keep those other skills, sharp too, especially when you're new and you're in that phase where it's easy to forget some simple things like that. So I'm going to start in with codekata's Kata02 problem, and I'll jump that over here. So the Kata1 was just some like an overview. You weren't actually coding on anything like that. You were just it was like, well, here's a problem, and here's some of the things you want to think about with these problems, and how would you resolve these few things. It was just a mental exercise more than anything else. The Kata2, we actually get into a programming thing where like this is what they want, a function that's called from chop, and then they provide you with test data for your testing class. So this first one's pretty simple, and you can see I actually already been doing some research, and it uses a binary search. And I was wanting to find, without algorithms, I mostly just wanted to find an image I could use to kind of explain. If you haven't seen what a binary search is, essentially a binary search, as assuming you're looking for like a value in pre-sorted data. And in this specific problem, we're assuming that there are no duplicates, and of course that everything's ordered properly. And then what you do with a binary search is the first thing you do is you cut the list in half and see, is that in this case we're looking for the number 4. You cut it in half and say, is this number larger? And it's like, no, it's actually smaller. So then okay, so the value I'm looking for is in this part of the array, not this part, and we just cut out half of what we're searching for. And then you jump around and narrow the scope down. So that's essentially what it is. And what they what they put down, they do list a pretty good definition for it. So we find the position in a sorted array. It achieves some efficiency by having the number of its items under consideration each time it probes the values. The first pass determines whether the required value is in the top half of the listed value. So this initial search determines if it's up here or if it's down here. In the second pass, it considers only this half. Again, dividing it in 2, it stops when it finds the value it's looking for. So the idea is that you would cut this in half. Now, what I find interesting about this, which I guess, okay, so, and to be fair, this is just an image off Wikipedia, so it may not be the most accurate. So what we're going to do is, assuming we had an array like this, the first thing we're going to do is cut it in half and see, is this value, first off, is this the value we're looking for? Because it could be. And when that turns up a no, is it larger or smaller? And then we'll take just this half here, the 1 to 6, because we just ruled out this one, so this is no longer needed. So now we just have these 4. So then you cut this in half, and then you have to ask yourself the question, am I rounding up or down when cutting in half an even number? For our purposes, you can see here they rounded down, so they took this value instead, and then they were like, well, is it here? No. And then so they had these 2 values left because they just ruled out this one and that one. So they have these 2 values left, and then for some reason here it rounded up. So that's why I'm like, okay, this just doesn't make sense, but I think they're just trying to show the back and forth nature. But essentially, though, you're always cutting in half. So we cut this in half, we cut that in half, we cut this in half, and that will eventually get us down to the number we're looking for. And you can tell, on big data sets, that can be beneficial. So that's what we're going to do. The first thing we'll do is, I actually don't even have the project set up yet, so we'll get the base project files set up and running, make sure the tests are firing off properly with the dummy data. And then we'll do some test-driven development. We'll get these tests put in, and then we'll start writing out the code to complete those tests. The first pass, what we're going to do is just write out some basic search features, and then we're going to try and Rubyfy it. And that's, look into like the special map functions, and is there a way we can be annoying with it, right? Get it production ready. I say be annoying with it, and I just mean just the Ruby aspect, that it has to be done in a certain Ruby-ish style. But it's important when you're applying for a Ruby job to show that you actually understand there is a map feature, and there's these functions that don't exist in the standard library of other languages. Most do, but Ruby has its own way of doing things, like many programming languages. So that's what we're going to get jumped into. Now there are some goals. So we'll read through those to make sure we are hitting them. And that is, as you are encoding each algorithm, keep notice of the kinds of errors you encounter. So, this one is, since we're dealing with arrays, we may be dealing with off by 1 errors, Fence post errors as you progress through the week. I don't know why this would take us a week, but I guess it's assuming you're new. And you haven't dealt with these before. I've dealt with binary searches when I've been learning programming, and you could get some algorithms if you go to this Wikipedia page. Like I said, I didn't actually go through it. I just came here for the image. Actually, I was hoping for an animation because Wikipedia from time to time has really cool animations showing how this stuff works, but they didn't have one for the binary search. Anyways, so what can you say about the relevant metrics of the various techniques you've chosen? What is the most likely to make it in protection code? Which is okay. Which is the most fun to write? Which is the hardest to get working? For all these questions, ask yourself why. So this is a little bit tricky. So which is the most likely to make it into production code? If you're new to programming, that might be hard for you to be like, oh yeah, well clearly it would be this one. Yeah, so that's interesting. That's an interesting goal. It's fairly hard to come up with 5 unique approaches to the binary chop. Oh, am I actually supposed to do 5? Alright, well, that's probably what it is then. That's why it says a week. Yeah. So it's come up with 5 different unique approaches. That's actually really good too, because they get you to really think about like because there's more than one way to solve a problem. Okay, so that actually makes that one make more sense. So we have to come up with 5 approaches, and that's why it also says a week. So we'll definitely only come up with maybe 1 or 2. Like I said, we'll do one that's going to be like the quickest to write, and then probably one that's more Ruby-ish in nature. But that is good. Alright, to write a binary chop, it takes introduce search. There's the spec. Okay, so yeah, that's not too bad. And it's one of those where if you're doing this for job interview stuff, it could be good to make sure you do that, because in a job interview, they're not going to have you come up with 5 different ways to do a binary search, but they may ask you, why did you choose the way you chose? And if you only know one way to do a binary search, what if they tell you, okay, well, we're going to put this ridiculous constraint that you can't use this base class or something like that, or you can't use that one method. And of course you're like, well, in a real world situation that would never happen, but the idea is to make you think on your feet and see how you do in other ways, and they may be even just trying to lead you to a more optimized solution. So doing 5 unique approaches actually could be a very good thing for you to do, and I challenge you to do that. Unfortunately, I don't have time today to do 5 unique ways, because I have to jump on and start working at my day job here soon. So yeah, so that'll be the goal. I'm gonna take a break real quick, as we've been in this for about 15 minutes now. Before we get in, we have a bathroom real fast, and yeah. So I will be right back. Alright, got some coffee brewed. And, that's interesting. Am I having video issues? Where are my internet's doing? Our internet, well, we're on fiber right now, but it has been questionable lately. They've been trying to expand a bunch in town, so, you know, all this construction going on and upgrades, so it's been a little spotty. Anyways, so yeah, so we need to get this project set up. Let me jump to coding. And let's see. Alright, well, we're going to call this Kata problems. And I know it's not on the screen right now. Let's get a new. Let's see. Alright, so this is what we'll work with. Alright, so I went in and just made a single project that I'll end up working in each one in. Just see what we have in here. So we have a bunch that we don't need. Oh, this is a full Rails app. Yeah, I grabbed the wrong. I have a templated project, which there's a blog post on that on my blog at programpractical.com, how to set up a skeleton project. And I just copied over the wrong one. Well, let's see. What about this one? Apparently, I don't have. I recently got a new computer. Apparently, did not move my skeleton project over. But I'll tell you what. I have one that was built from it. We'll just use that. I had one specifically for some algorithms that I was working on, or working through, I should say. Clean up. Okay. Let's see. Kata. Alright. And grab a new window. Make my font size a bit bigger. And no, none of this is really required to be updated, but you know, it's always nice to have these things done. What is that website called? Okay. I want to rename this to Katas. I'm just gonna name that Katas like that. Alright, there'll be a few things we'll wanna fix here. Katas. Katas. Name Katas. We'll leave that in there for right now. We'll get rid of it in a second, but I have test Roman numerals. So the way we'll name this is just after the katas themselves. So this is Kata02. Now I'll just rename this. Let's see. Rename Kata02. And then we have a test. This is going to be testing Kata02. So yeah, I'm just gonna say test katas. I don't think there's a reason. I mean, organization-wise, there's a reason, but let me just grab this test data right here. I'm just gonna throw this in here. Make sure that spacing's right. Test chop, the Kata02 test. I'm also going to change this. Not sure why I hard coded it like that. Okay, there's that Ruby. And then here we'll put a require kata02.ruby and try that. It's supposed to just have a method chop. I don't think so. I don't let me make sure this is right real quick. I didn't change your name. Name. Okay, that looks good. So we'll close the gym spec. Let's see. Should work just fine. This we'll want to change. So we're not doing a model in the test, we're just having this method chop. So we really should just have to define chop like that. And you'll notice up here it mentions that we should be taking in an int, which is the what we're searching for. So we're going to just call that target. And then we have our arrays of integers, and that's just going to be list, is what I want to call it. Yeah, or scope there. Okay, we'll do that. And then it's supposed to return an integer, and we see from the test it's supposed to return -1, 0, or 1. Right now we're just going to return -1, and that's so we can just test that these files are doing, that everything's set up properly. You know, give it a quick test, make sure things are running right, and then you know, if it's not, then we know we need to research this and figure out what's wrong, because we did just copy over a project, so it wouldn't be crazy that something's not configured right. Yeah, so which I just thought of that. I need to check my rig file since that's what we run our test from. So it looks like there shouldn't be anything in there that would tell us we have a problem. Alright, well, that looks like it should be fine, so I'm just going to bring my browser in here real quick, and we're just going to see if we can do a rig test. And we do get a cannot find such files, Kata02, load error. So that would be inside our main file here. This is where we actually call that. Can't find it, huh? I wonder where it does its scope from. I wonder if I actually have to do CLM. There we go. So yeah, I just forgot to add the lib in there, because that's doing a project root, not my current folder. You know, you have to remember in terms of the root. So fix that little error, and now we have this working. So of course you'll see that there's some errors because all we're having to do is return -1. So some things pass, but not all. In fact, we get through the first two. So part of test-driven development is you just start with a test and start working from there. So we're gonna grab this now that we know we have everything in there properly. Grab this to the side. And so I'm looking at YouTube right now, and it is, I don't know what is wrong with my stream quality. Hang on, let me check this real quick, because there's no way those numbers are readable. Or there we go. Okay, hang on, let's see. I'm making sure that you guys can actually see the text properly. Yeah, okay, so the string quality is good. So like it's getting the frame rate, which if I think I remember correctly, I have this set to a lower frame rate since it's just text. Anyways, so dealing with this, you can see that, you know, first you have to be able to handle a bunch of different options. We may get an empty array. We may get one that only has 1, 3, and 4, and we have to deal with those properly. And then it's looking for either -1 if it doesn't exist, or the position, specifically just the index. So that means like here, since it's in the first position, the position is actually 0 because of course arrays start at index of 0, not 1. So that's important to remember. Okay. So we'll want to deal with a few things. And the way I like to do this, jump into here and look at pry. So we could be dealing with, like, the first one, getting an array that is empty. So this would be our empty array. Now, with an array, we have a lot of different methods available. And one of them, I can find in here, is empty, which should tell us if a array is actually empty or not. Is it just that? And in this case, you can see it is true. So if we had an array with 1, it would be then false. So that's the simplest, easiest thing to do, and something we need to start our check with before we try and divide it up. The question is, does it even have anything? So we can pass that test pretty simply by saying if the scope is empty, then -1, and then that would pass that first test. So this is part of, like, with test-driven development, slowly building up through your tests. So now you see we fail on the second one because it's not empty. There's actually something there. Now the question is that actually optimized? Because we're going to want to jump in and cut the array in half. Jump back into pry here. So I'm going to set up 2 arrays. We'll set one that's empty. We'll set one that has 1 in it, and then one that has 2 in it, real quick. Alright, so we have a few different arrays. So there's a few different optimization checks we can do. We could jump in straight and see, well, what's it cut in half, and what does that look like? We could also just do an initial check just from the get-go and say, check to see if it's empty, or check to see if it's greater than 1. You could call length on it and see, how, what does this have, and what does it give us? Oops. There. And so you can even call it on the empty one, and it will tell you there is none. It's 0. There is no length. Which in that case, you'll be like, oh, well, then that should probably just be -1. Oh man, I'm stretching out my back a bit. So how we want to resolve this would probably be with a couple of different checks. And what we'll want to do too is probably build out, I want to say probably the best way would be with recursive, with a recursive logic. That's something I have to think about. Okay, so this might take a couple functions, but we'll see what we can get done. So the first thing we'll want to do is we'll just focus top down. So we'll let this code get more complex as we go through it. So as of right now, is it empty? Says no. Else if scope dot length is 1, then you can do a quick test and just say sorry, I'm I'm having a brain fart right now. Oh boy. And unfortunately, I'm going to let my dog out real quick, or hang on real fast before this gets loud. Alright, dogs are outside. Jump back into this. Alright. Anyway, so we can do a quick check and just say, let's see, target equals scope first. So if it equals the scope first, then, well, I guess we can, or I guess it would be 0, but we could return 0, else return -1. So the way this works, we'll give it a quick test. Oops. Error. Do you mean target? Oh my goodness. I've been on and off my mechanical keyboard lately, jumping between my Mac keyboard and my mechanical keyboard, and it is catching up to me. Okay, so yeah, so all those passed. So what this is a trinary operator, if I'm pronouncing that right. So what's happening here is you return one of these two values based on a Boolean argument. So here I'm saying, does this equal this? And this first argument is always the true, and this one is the false. And a lot of languages support this. There's a few annoying ones that don't, because I really like using these because it's an easy way to just bang out a true-false logic if you don't have, if it's not too much typing out, your lines get too long. So I just do, target equals the first element in the scope. If so, then return this. Now there are some issues with this logic right here that will come up later. For instance, if we split this in half and the solution is like out here, like for example the 5, and we take this array in here, and then it's going to go, oh yeah, you were the first one in the array. Oh, I guess it wouldn't, for that one it'd be more like this one here, where it splits it in half and goes, it's not here, must be in this one, and then it hands an array back to it, and then the array is only 1 in length. It's going to go, oh, it was this, and it's like, well, it was 0, but that was really a few in. So we'll have to deal with that. But for right now, we are passing the first 3 tests and jumping on to here where it breaks next, which is what we were expecting. So now we're dealing with an actual array. So this thing's going to have some beef, and we actually have to start typing out an algorithm that does this binary search. So the first thing we want to do is see the length divided in half, and of course test what that is. So a way to do that in Ruby, let's say we have an array like this, and it has a length of 3. You could divide that by 2. Oops. Cause myself problems. Let me think before I type. Anyways, you could take the x dot length, divide that by 2, and you would get 1. Another way, let's see, we took the mod to almost 1. So that'd tell us to go 2n. Or that would go 0, 1, 2. We could use that. With 0, 1, we could use that. Now on a shorter array though, you know, they always tell you don't divide by 0, right? So if we had an empty array and we did that, equals, and you said I wanted to do you still get 0, so that would be good. That'd tell you the first element, and we added 1 element in there. Tell us 0 again. So actually that does work if we just want to divide the length in 2, and then use that as an actual index value. Because that would tell us, it would land us in the middle here and in here. Now, a good question is, how does that handle? So it would tell us to go here first, and then on a for option 1, it'd be 0, 1, 2. So it would go land us here. So it would be a rounding up kind of system, but that works. And I think, you know, and you know, normally, yes, you don't divide 0 by anything, but, or I guess it's divide anything by 0. That might still work, but anyways. So this is a good way to cut it in half for us. So I'm just going to continue building off this, even though that's not necessarily what we're wanting to do. Alright, so otherwise, so we know it's not empty, it's not 1, and you know what, actually, I bet you, hang on, I want to try this real quick, because it's something I didn't think about. Let's see, that's still return -1, because technically the target is not equal to the scope, because the first is going to return nil. So yeah, so this is actually not needed. You could just take this down to there. Now, note again, this is in the Ruby language. Other languages that would not work in, because it would say you would be out of index, right? I mean, if you did a scope first in any other language, I mean, although first doesn't really exist in other languages, but if you were to do that, it's like, whoa, that's not gonna end well. But because we're in a Ruby language, since we're in the Ruby language, we can do, I didn't mean to take that far. We can do stuff like this, and then it accounts for it. And then what you do here is say if the length is less than or equal to 1. So here's 0 real quick to that. So now, when we do that, you'll see, actually, I return that one too, but yeah, so you'll see that that works. Hang on, dogs are running in. All right, well, they've had their morning potty and are back inside. So now we have already found a way to optimize that a little bit thanks to the Ruby language. So now we are in an else situation. So we know the length is over 2, and there's some thoughts to be had. So we could take a half value, which we've already shown in pry works well, where we can take the length and divide that by 2, and then that's going to be a round up kind of logic. So for here on these numbers will be the middle third, but when you get up to here it's going to be grabbing the 5, and that's specifically the index. So it's going to be cutting that in half, but for stuff like, you know, if it was happening on these, it would return 0. If it was happening up here, it's going to be returning 1, which still index-wise, 0, 1 works well. So that's actually pretty good. So what we can then do is just do a quick check. You know, does the scope half equal our target? And if so, we can just return the half. Now this probably won't run because of course it's breaking here, but it would run here, and we can show that. So I'm gonna break that test real quick, and there. So it is passing this test and failing on this one, so that's not too bad. Oops. All right. Now the issue, of course, is we're not really dealing with the situation at hand of if this isn't right. So you do want to check before, you know, running numerous calculations on is it greater or less than. You first need to know, was it even right? You know, did this proper. And then, you know, we can see yes it is, or no it's not. And then we can do an else if, and I'm just gonna grab this real quick. We'll see, is the scope larger than the target? So if it's larger than the target, then we know that target is in lower half. And you do an else, but the fact of the matter is, if it's not at the target value and it's not below it, then we know the target is in higher half. Okay. Stuff like that. So if it's in the lower half, then what we want to do is, keep doing that again. We want to cut it in half and try it again. So now we get into an interesting situation that, we can keep doing ifs forever, or we can do some kind of a recursive function. If you're, depending on how new you are to programming, recursive essentially means we're going to call chop again and have it chop in half. And it's just going to keep chopping down until it finds what it's looking for. Now, a problem with that, of course, is it doesn't have context. So if it was in the upper half and it chopped, we would lose sight of where we were. And then that can be problematic. So to kind of show that, let me just, I'm just going to say -1 down there so it has something. And then actually -2, so we don't need any false positives. So if we were to run this again, right? So chop, and then give it the same target. And this time for the scope, we want to give it specifically only the half that we haven't done a check on. And so you'd want to give it a range. And there's a few different ways to do ranges here. So if we had an array like that, and then we had a half value of 1. You can do ranges like so. Oh, wait. Undefined method x. Oh, maybe yeah, there we go. And then you can even do that with variables. Now that's an inclusive. You can do an exclusive though, which would just return that. And that's actually what we want to do, the 3 dots. And the reason why is because we've already established the half is not the variable we are looking for. So there's no reason for us to include the half in our equation. So we do want to cut that down, and that'll help solve the issue in less amount of runs depending on how large the data set is. So what we'll do is we'll say 0 up until, but not including half, by using the 3 dots instead of the 2 dots. And then once that returns something, that'll return it there. So we can try and run this now. And you'll see we get past, oh, did I still have that? Oh, I didn't save it. Okay, So you'll see now that we get past both of these, and that's because this first value was here. So we are iterating through, it is chopping in half and then going towards the next one. Now the problem here, of course, is how do we get to 5? Because it's not returning the proper value. In fact, we return -2 because we're in the higher register. Now the problem with this is if I do chop here, but just treat it differently and say, hey, I actually want to start at half +1 and go up to, but do not include, because once again we don't want to go outside the length of this thing. I'll show that again here. So if we know half is the one value, so we've already tested half, so we don't want 3, we just want to go up, but we don't want to include the last bit, and it's kind of hard to show with the 3 variable one. But if I grab x dot length, actually does work, yeah. So we grab the length, but we don't include it, which once again, it's because we're dealing with a higher level language. I'm still trying to get around that, the fact that Ruby is so safe in how it deals with things that it's like, well, coming from C, I'd have so many out of scope issues, that if I was doing something like in the C language, I would have to do scope dot length -1 to make sure I'm staying within the bounds. So here you'll see that we'll run that, and we have an issue. So we expected 2, but we got 0, and the reason why is because we are not keeping track of how far in we are. So while we can solve these lower register ones, as long as it's continuously in the bottom of the register, we're not dealing with the fact of, well, what happens when we run through this array and we're in the higher portion. And to do that, we'll want to keep a track of our half value, or yeah. So what I'm just going to do, I'm going to make another one called carryover, and I'm going to start that at 0. So what this does is, anyone who's new to the language, or I mean a lot of languages have this, but new to programming, we're defining a third value, but we're giving it a default set value, which means you can still call this and only pass in 2, and we'll make up what the third option is. Or you can override that option with your own value and handle that appropriately. Now there is one issue with what I typed right here, and that is we're going to be resetting that carryover each time. So what you're going to want to do is half plus the carryover. That way that's always being calculated into the increased, or every time you do this loop, it's being calculated. So now when you do this chop, you're not going to want to do just, or yeah, so we keep looking for the proper value. So you're not going to want to, when you get done with this and you get all the way down here, because this is essentially what you're going for, is you're shooting for this. Or you could be in one of these lengths. Essentially what you want to do is you're going to want to take into account the carryover into your value. So if the scope length is less than or equal to 1, then we're just going to make it equal to the carryover, because of course by default it's going to equal 0. And then if it's this one, since it's supposed to be the half, we'll want to make sure we account for the carryover. And those two carryover checks should deal with the rest of this just fine. And we're going to double check that. Okay, and we do still run into an issue. We handed it 1, but it was expecting 2, right? No, it got 1. Oh, here it is, yes. We're expecting 2, but we got 1. Okay, so there's definitely a flaw in the logic. But on the bright side, notice that it did get all the way back down to here, which means this carryover and right here, this carryover plus half is working. There's just an issue still with the go through. We'll figure out what that is. So we were expecting 2, but we got 1. So the half value was 1. And then it sent over a base method and got trapped there. Well, that's interesting. One way we can visualize this, trying to think of a way to make this to where we can see it easily, is we're just going to output our data. Okay. And you'll see that let's see if that's any better for us. Okay, slightly better, yeah. See if it respects line break. There we go. Okay. So what we have here is our target, our array, and our carryover. The issue we're having is with the very last one. We have our initial setup, and then once it goes through, the half value is 1, and it comes through, except for now we're in this issue where the new array is only 1 in length, which means it's hitting this right here, and then it's just returning the carryover. It's not accepting the fact, though, that there is a new, or that your 1 value in. So the way you would have to deal with that would be to take into account you'd have to take that into account. Let me try something real quick. Let's see what this does real fast to the output. I didn't mean to open that. And then that's going to give us an issue. Yeah, see, that's going to be so you do need that initial check. Oh. So we do that. We do need this check up here, unless we rework this. Because they can't do a check like that on nil. Because that's the problem. That's going to be a nil value. I guess if we let me try this real quick. Let's just I'm interested to see how this function works. If it was just get past this initial one. So I'm still getting 1 back. Now, am I actually considering this properly? Because maybe the issue isn't with this methodology. The issue could just be the fact, something I probably should have thought of earlier, that the carryover isn't enough, that I need to do a +1 because, and this is the reason why I say this, or the half needs to be added. Because okay, so when we cut these in half, we have 0, 1, and 2. Right now I'm giving the value of this, and I'm saying the carryover, but technically we really need that index to be looking 1 more, because we're no longer considering this. This is the new 0 value, not this. But by doing half plus carryover, we're still setting our 0 index technically to this instead of this one. And there we go. We were so close, and then I went off on a little side tangent. So yeah, so this is solution 1 of this, and you saw we did some optimization along the way, primarily how things were being handled up there, but this is you know, a good solution that does some recursive function where we are splitting it in half and then just looping through each one to figure out what's going on. Some ideas on another option though. So we're built a few if statements in. I'd be interested to see if you could get this down to a single indentation. In other words, remove this length up here and have it just like something down here. You'd have to have it deal with the whole empty array somehow. Now, of course, I mean, you could just do a quick fire off of this method in a one-liner, but that's for another day, another time, not necessarily another day. And we don't want to edit this too much because, you know, you're supposed to try and come up with 5 different solutions. So I would, you know, mark what I would do if you're following along and want to kind of continue on with this thing, which I might come back to and keep trying different ones. I would just say this is solution 1, and then make a solution 2, and then just comment this out and create a new function below, so you keep track of how you solved it in the past. But yeah, this would be my default one. Just go to a recursive method. I like recursive methods because you're just using the logic that you already had existing. You know, just a slight, you know, one more variable that's optional, allowing us to keep track of as we're ticking through this thing. And yeah, so that is sorting a binary tree without too much thought. You know, just kind of going in and free coding this thing. I mean, yeah, so a lot of roadblocks I hit mostly involves overthinking, and it's one of the dangers coming from a different language. You know, there's a lot of special Rubyist things, like this, you know, first method, how ranges are handled, and the fact that, you know, this right here would cause an error in C++, because we're calculating the length, which would be 1 outside of the array. But in Ruby, it handles that. So typically, if you're watching me struggle along and you're like, well, why is he doing that? Coming from a different language, some of these things can be difficult. And, you're dealing with things that in a scripting language like Ruby, the interpreter takes care of for you. There's assumptions, or special things like the first character, which on a nil array that would cause issues, which it mentioned on the website. What are errors you're running into. One of the issues you're most likely run into is index out of bound. In a language like C, C++, yes, you're going to hit those a lot. Where in Ruby, you're given a lot of leeway, and that's one of the beautiful things about Ruby. So that can be tricky. And that's one of the reasons why they say don't try optimizing until the code's written, because you end up over optimizing and doing things that that's not an issue in this language. And one of the good reasons why you should be practicing, kind of show you the different things you can do in a language. And all that stuff. Anyways, guys, it's been great. It's been about an hour and a half, so I'm going to jump off here and get to my normal job, writing a Rails app. And I should probably be back on. I don't know if I'll want to jump back on, if I'm going to keep on with these different ways of binary tree. That'll probably be something I'll do offline. I'll probably jump into another problem. Thanks for watching me stumble along this thing. Like I said, there's no pre-planning for this other than what I already know about binary searches. So it was a fun little run through. But anyways, thanks for watching, guys. Again, this is Nick with Program Practical. You can find us online at programpractical.com. More info at ollis.me, ollis.me. You guys have a great day. Happy Friday.